Have you ever wondered what makes a line or a plane in the world of geometry? A question that might seem baffling at first glance, but as we delve deeper, it unveils the beauty of mathematical reasoning. When we think of lines, planes, and other geometric shapes, we often overlook the basic element that constructs them all: the humble point. This seemingly insignificant dot is the cornerstone of all geometric structures, the alpha of their existence. Without it, there would be no lines, no planes, no circles, no squares, nothing. It's like the atom in the universe of geometry, invisible to the naked eye yet omnipresent in every formation. The point, in its purest form, is the embodiment of position without any dimension, a paradoxical entity that creates dimensions. So what makes a line or a plane a plane? The simple answer to that is the concept of a point, the most fundamental building block in geometry. So, what exactly is a point in geometry? That's a question that might sound simple, but it's a concept that holds profound implications for our understanding of mathematics. Let's dive into the primitive concept of a point in geometry. To put it simply, a point is a location. It's a place in space or on a plane, but it's a place that's not defined by size or shape. It doesn't have a width, a height, or a depth. It doesn't have dimensions. It's a place that exists solely by its position. Imagine for a moment that you are floating in space. You're not near any planets or stars. You're just there, in the emptiness. Now, in that vast emptiness, you decide to mark a place. You don't draw a circle or a square. You just mark a spot. That spot is a point. It's a location, but it doesn't have any dimensions. It's simply a position in space. Now let's bring this concept down to Earth. Think about a map. On that map, there's a dot indicating a city. That dot is a representation of a point. It's indicating the position of the city on the map, but it doesn't tell you anything about the size or shape of the city. It's just a location. In geometry, we use points to define other shapes and concepts. Lines, for example, are defined by 2 points. A line segment is the shortest distance between 2 points. A circle is defined as all the points that are a certain distance from a central point. So a point is a fundamental building block in geometry. It's the most basic unit, and yet it's a concept that's incredibly powerful. Because from that simple idea of a point, we can build up all the complex shapes and structures in geometry. In essence, a point is the most basic unit of geometry from which all other concepts are derived. But how does a point, this most basic concept, fit into our broader understanding of mathematics? Let's delve into that. First, let's consider algebra, a branch of mathematics dealing with symbols and the rules for manipulating those symbols. In algebra, points are often visualized on a graph. Each point represents a solution to an equation, and the coordinates of the point are the values of the variables in the equation. Therefore, points give us a tangible way to visualize and understand algebraic relationships. Now, let's move on to calculus, a branch of mathematics that studies continuous change. Here, points are used to define limits, derivatives, and integrals. For instance, the derivative of a function at a certain point provides us with the slope of the tangent line at that point, giving us insights into the function's rate of change. And then we have coordinate geometry, where points are used to define lines, curves, and surfaces. Each point in this space has a unique set of coordinates, and by connecting these points, we can draw shapes, construct figures, and even model real-world phenomena. Moreover, points are not just confined to 2 or 3 dimensions. In higher dimensional spaces, points help us understand complex structures and phenomena, from the shape of the universe to the behavior of particles in quantum physics. In essence, points are the building blocks of mathematical constructs. They are the atoms of geometry, the starting place for all shapes and forms. Without them, we wouldn't have lines, planes, or any other geometric figures. Without points, the mathematical world as we know it would simply not exist. So, you see, the humble point plays a pivotal role in shaping our understanding of mathematics. It's more than just a simple dot on a piece of paper. It's a fundamental concept that underpins much of what we do in the world of math. Now, isn't that something to ponder upon? Now let's delve deeper into the relevance of points in modern mathematics. In the grand tapestry of mathematics, points are the unseen loom upon which complex concepts are woven. They have evolved from mere geometric primitives into indispensable tools for understanding and modeling our universe. Consider point set topology, a branch of mathematics that thrives on points. Here, points are no longer confined to the 2-dimensional plane of geometry. They leap into the abstract, existing in spaces of any number of dimensions, even infinite dimensions. Point set topology is like a playground where points roam free, unrestricted by the rigid rules of geometry. It gives us the ability to study continuity, convergence, and compactness, impacting areas as diverse as quantum mechanics and economics. But the story of points doesn't end with abstract mathematics. Points have also found a home in the world of technology, specifically in computer graphics and digital imaging. Here, the point is reborn as the pixel, the smallest unit of a digital image. In this digital realm, points are colored and arranged in arrays to form images that our eyes perceive. From the stunning visual effects in blockbuster movies to the simple graphics on your mobile games, none of it would be possible without points. Moreover, points are pivotal in the field of computer vision, an interdisciplinary field that enables computers to gain a high-level understanding from digital images or videos. Algorithms identify and use points to recognize patterns, track movements, and even enable autonomous vehicles to navigate our roads. In the world of data science, points represent individual data entries in a multi-dimensional space. They are used in machine learning algorithms to find patterns, make predictions, and help us make sense of the massive amounts of data we produce every day. Indeed, points are far more than just dots on a paper. They are the invisible threads that weave the fabric of mathematics. So, what have we learned about points in geometry and their relevance in mathematics? We embarked on a journey to unravel the mysteries of a simple concept, the point, and discovered a universe teeming with ideas and implications. We started by confronting a baffling question, the primitive concept of a point in geometry. It's a concept so basic, so fundamental that it's often overlooked. Yet, it's the cornerstone of all geometric structures. Without the humble point, there would be no lines, no shapes, no solids, no dimensions. We then delved into understanding the point itself. A point, we learned, is a location. It has no size, no dimension, no depth, no length, no breadth. It's just a position in space, an abstract entity that can only be described in terms of its relationship with other points. It's the ultimate simplification, the reduction of all complexity to a single dimensionless entity. From there, we explored the point in a broader mathematical context. We found that points are the building blocks of numbers, coordinates, vectors, and functions. They are the atomic units of mathematics, the indivisible entities from which all mathematical structures are built. They are the silent, invisible workers, laboring behind the scenes to construct the edifice of mathematics. And then, we ventured into the realm of modern mathematics, where points take on new roles and meanings. We saw how points as abstract entities can represent complex concepts such as states in quantum mechanics, nodes in network theory, or pixels in digital imaging. We saw how the concept of a point can be extended to higher dimensions, leading to the creation of mind-bending geometric structures like hypercubes and hyperspheres. We saw how points, in their simplicity, can encapsulate the complexity of the modern world. Throughout our journey, we saw the point in various lights from different angles through different lenses. We saw it as a primitive concept, a building block, a tool, a symbol, a metaphor. But above all, we saw it as a powerful idea, an idea that transcends the boundaries of discipline and culture, an idea that lies at the heart of human understanding and creativity. So as we wrap up, let's take a moment to appreciate the humble point, the unsung hero of geometry and mathematics. It's a simple concept, yet it's filled with profound implications. It's a tiny speck, yet it's capable of creating vast structures. It's an abstract idea, yet it's deeply connected to the concrete world around us. The next time you look at a geometric figure, remember it all starts with a simple point. The point is the alpha and omega of geometry, the beginning and the end. And with that thought, we conclude our journey into the fascinating world of points.